Hello and welcome to the first episode of what I'd like to be a secondary series on this channel. The main focus of this series is going to be how binary numbers work and how computers work with them. And from then we're going to go into Boolean logic, logic gates, and from there we're going to go into higher and higher level components until eventually we have our very own CPU, which will have its own architecture, or maybe we'll base it off something, who knows. But for now, this episode is only about binary logic. So, we have a blank piece of paper. Here's a number. Here's the number 37. So, how do we make that into ones and zeros? Like, you can't just, I mean, you could probably do something like, this is lower, so it could be 0, this is higher, it's higher than 5, it's a 1. That's how computers do it. That makes no sense. So, what they do instead is that we take this 37. So how you can imagine numbers like these, basically all of these are like a power of, like based on powers of 10. For instance, like 37 is nothing other than 3 times 10 to the power of 1 plus 7 times 10 to the power of 0. Simple enough. What about, I don't know, like 5075, for instance. Well, it's also rather simple. 5 times 10 to the power of 3 plus 0 times 10 to the power of 2 plus 7 times 10 to the power of 1 plus 5 times 10 to the power of 0. Same thing, same result. So, how do we convert this to a binary number? Let's go with 37 because it is simpler to work with. Everyone knows, binary numbers just like 0, 1, 1, 0, 0. Those patterns are not random. Those have purpose. Let's think to this here again. Binary is only two kinds of numbers. It's either on or off, true, false, 0, 1, whatever you want to call it. It's just two states and nothing else. With decimal, you have 10 states. Let's think back to this example, but try to imagine it in binary. So, binary is 2 elements and decimal is 10 elements. So how do we do it with 2 elements? But it's essentially like this over here with the powers of stuff. Basically, we've got, let's take the number 37 like before. Let's think back to our powers of 10 example right here. The first bit in this row of bits, this here is the 2 to the power of 0th bit, also known as 1, which, simple enough. After this, we have 2 to the power of 1th bit, also known as 2. After that, we've got our 2 to the power of 2, which is 4. After that, we have 2 to the power of 3, which is 8. And it continues on like that, 2 to the power of 4, that's 16. There we are. This is our number system. Now, how do we make this decimal number into a binary number? You can think of it as just subdividing it into until it fits. Let's start with the biggest denominator. So, we can instantly agree that start with biggest denominator. Let's see which one of these is closest. We can instantly see 32 is closest. So let's see. Let's just make a 1 here, 32. So, how much do we need from 32 to get 37? 32 plus 16. That's way too big, that's 48. 32 plus 8, closer, but it's 40. It's still way too big, so we make that a 0 as well. Now, 32 plus 4. That seems pretty close. Brings us closer. Make that 1. Now we're at 36. 36 plus 2, that's 38. That's 1, that's too far. Make that a 0. Now, 36 plus 1, that's 37. And here we have the binary representation of 37. Now, let's do this again. Let's go with the previously mentioned 5075. 5, 0, 7, 5. I'll start writing them down. So, 1, 2, 4, 8, 16, 32, 64, 128, 256. Well, looks like we're out of bits. Like, look at this. Doesn't look like we have enough space for this. I mean, we've already gone beyond 32, so, you know, this number isn't going to fit in there. How do we fix that? Well, you just add more bits. That's how you do it. So in this case, to display the number 5075 in binary, we need 13 bits. So, let's write that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's quite a big number, isn't it? I'm going to run you through. Alright, so 5075 equals, so let's go through. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 248, 4096. Right away, we can already tell that we need this 13th bit right here. So, let's make that a 1. To that 4096, let's add 2048. That's 6144. That seems a little bit too big for our little number here, so let's make that a 0. Next up, 4096 plus 1024. Well, 5124 is closer than before, but that's a 0. That's way too big still. 4096 plus 512, that is 4608. That's decently close to what we're trying to get, so that's a 1. Now, plus 256, well, that is 4864. Again, we're getting closer. That's good. Let's make that 1. Let's add 128. We get 4992. Again, we're getting closer. We're getting there. Make that 1. We're at 4992 plus 64 is equal to 5056. We're extremely close now. That's really good. Add that now. Plus 32. Now we're at 5088. That's way too big, so it can't be 32. This is 0. 5075 plus 16. That's 5072. Very good. Let's continue like that. Now, we'll speed this up a little bit. We can already tell 8 is going to be way too big, because that'll be 5080. Way too big again, so that's a 0. Number 4, that will be 5076. That's way too big again. 5074. That's closer, and 5075. Here we are. This is 5075 in binary. But for now, these are the basics of at least making decimal numbers into binary numbers. I hope you enjoyed this admittedly rather messy episode of, I guess, learning computers. I'm going to call it that. That sounds good. Yeah, hope you enjoyed this episode of Learning Computers. Have a nice day, and see you around. Bye.